Alright, so in this example, I have f of x equals the square root of x plus 2 minus 4. I'm going to find the inverse, so I'm first going to turn f of x into what? Y equals square root of x plus 2. Whoops, made my minus too big. Class, what do you do with your y and your x? So now I have x equals the square root of y plus 2 minus 4. Yes?
Yeah.
So I'll write it here. So I have x equals the square root of y plus 2 minus 4. What am I going to do next?
Add 4 to both sides.
We're going to add 4 to both sides. Remember, just like the absolute values when you're solving them, you're trying to get the absolute values by itself. So I have x plus 4 equals the square root of y plus 2. We're going to square both sides like that says. Okay. Here I'm not going to expand x plus 4 squared. I'm just going to keep it as it is. And I have y plus 2. And if I subtract 2 on both sides, I'm going to have y equals x plus 4 squared minus 2. Are you guys okay what I just did there? I just subtracted 2 to this side and then I switched sides.
Yeah.
The reason why I do that is because we normally like to have the y on the left side. Okay? And then we just go back and replace y with what?
X and then negative 1. Or 1.
So I have the inverse of f of x is x plus 4 squared minus 2. Raise your hand if you got that. So let me write that down. Inverse of x equals x plus 4 squared minus 2. So we'll call this my green graph. Let's go ahead and graph this. Now, I always need to find, I'm always trying to look at my radicand or the denominator, and we're always trying to make it equal to what number? We're always trying to make it equal to not equal to 0. So if I put in negative 2, x equals negative 2. I get negative 2 plus 2 is square root of 0, and 0 minus 4 is negative 4. So negative 2, negative 4 is my starting point for my graph. Okay, we're going to learn next chapter about, or next section about transformations. This essentially means left 2, even though it says a plus sign, down 4. Okay, and then if I do it the other way around, I can just do it down here for you. If I make my y value equal to 0 and solve this, I add 4 to both sides. I square it. And I subtract it. What do I get? What did I just find, class? Somewhere way over here, that's where it's going to cross the x-axis, right? That's my x-intercept. So just really roughly, I want to show you that the graph kind of looks like this. Now, how do you find the domain of a square root? Well, you can look at it visually, right? And then we can also say this one right here. In a square root, do we want any negative numbers? No. We want what kind of numbers? Positive. Partner A till partner B. What do I set that equal to then? If I just want positive numbers. X plus 2 is? How do you say positive numbers, class, with inequalities? Greater than or equal to 0. If I solve this, x is what? Greater than or equal to -2. What does that mean?
So anything above -2 and or equal to.
Anything greater than -2, that's going to be our domain. So let's go ahead and write that in integral notation. Class, what's my domain?
Wait. North, left, right, is x-axis. No, the y-axis.
So domain goes from left to right, focusing on the x-axis. What number is that, class? -2. I can include -2. And where am I going?
Right, infinity.
Positive infinity. And how about my range?
-4.
We're starting at -4.
Including -2.
And where are we going? Remember, although it's not pointing up, it's saying that you can pick all these values. It's going to keep rising, right?
Yes.
Okay, so there's my graph so far. Okay, let's go ahead and graph this one now. Class, you notice what's the highest power here? So what is it going to look like? What's the basic graph? Quadratic, it's a parabola. So when we graph this, it's going to look like a parabola. Let's go ahead and draw our quick graph. I have this silly phrase I took from another teacher. Add to x, go west. Add to y, go high. Adding to x here means we're going to go left 4. Even though it says plus, we're going to go left 4. Something like that. That one's not proportional. So left 4 and then down 2. And I'll have a point right here. And you can also use your calculators and realize that is actually our vertex, right? And when you graph this, I'm going to graph it in pencil, and I'll tell you why in a second. It's going to look something like this, yes? Yesterday we learned, this will be my blue. Yesterday we learned that if you had to pick one sentence, if one of those instructions to summarize what the inverse is, a brand new student comes in here, how would you summarize the inverse? Picking one of those steps, not all 4. Which one would you pick? What does number 2 say? Switching the x's and the y's. The domain refers to the x's. And now it becomes our range. What's another way of saying the range? The y values. Okay? So when I graph this, my graph looks like this, but it's telling me that my domain is going to be -4 to infinity. Look at this. Is this -4 over here, class?
Yes. Yeah. Or like, no, that's infinity.
This is -infinity. This is -4. It's saying -4 going in this direction.
Yes.
Notice I only did half of the parabola. The reason why I'm only doing half the parabola because the domain from the original function of f now becomes the range, which we can write, and you'll see that when I show you the graph. And the range becomes its domain. So the range now, as you can see, it's -2 towards positive infinity. And let's talk about this last part. This is the new part. So all of that should have been in review. The last part is the inverse undos. Undoes, undoes. Everyone say undoes.
Undoes.
Okay, so watch this. You can copy this down with me. I'm just writing the original problem. If I write the variable x, tell me, class, what math operation is next to it? What math operation? Add 2. Yes?
Yeah.
And then all of that is what? Square root. And then that whole expression is,
Something minus 4.
so we say subtracting 4, or take away 4. Subtract 4. Okay? And what we did there is we did the order of operations. So I'm going to write on the side order of operations does. Order of operation does. It sounds kind of weird, but it'll make sense once I do this side. If I take the inverse of the problem, we solved it algebraically. And let's just say I still kind of write these 3 steps. But I'm going to put the x down here. Class, look at this x right here. What math operation is next to it? So I can say add 4. We're going in this direction, right?
Yeah.
And then what? So we're squaring it. And the last thing you're doing is what? You're subtracting 2. Oh, look at that. What do you notice?
Flip. I mean, like it's like the opposite.
They're opposites or inverses. Inverses undoes. So here I wanted to show you a couple of representations. Algebraically, how to find the inverse, how the inverse switches your domains and ranges. Graphically, it's being mirrored over. So if you did it on this side, the graph will kind of look like this. Something like that. You see how it's mirrored? It's just turned on that red line. And then down here, by words, I'm showing you what the inverse does. All right. Talk to your partner. Tell them 3 new ideas you learned as we went through this example. Ready, set, go.